In this part, we are going to solve some systems of equations by substitution. So the first step is to always isolate a variable. And so looking at these different variables in each of these equations, it might be easiest to get y, or we could get this x by itself. However, I think this y is the easiest to isolate because we have these minus signs in front of the other two variables that we'd have to eliminate. So this top equation, if we just add the x to both sides, we've got a variable isolated. So I'll go ahead and rewrite what it will be in a modified form down below. So I'll draw an arrow showing you that this is the one I'm modifying. And here's what it would be. It would be y equals, and then I'd have a positive x plus 1. Well, once we have a variable isolated, we've got an expression that it equals. So let's take that expression, x plus 1, since that's what y equals, it says, and we're going to put it in place of that same variable y, but in the other equation. So we'll rewrite the other equation, 2x minus, and then put in parentheses x plus 1 equals negative 5. Now I have to do that because this minus y is the same thing as the opposite of y. So remember what number you can put between a minus sign and a variable, or a minus sign and a parenthesis? 1. 1 was that number. And we have to distribute that over that sum. So when I do that, still left with 2x, but now it's a minus x minus 1 equals negative 5. So from this point, we can collect some like terms. We've got the 2x and the minus x. We can combine those. Plus, we can do an opposite operation at the same time. And we'll have our value of x. So now, 2x minus x, well, that just makes x. And negative 5 plus 1, well, they're opposite in sign, so we need to subtract. So we get negative 4. Well, from that point, we just have one more variable to solve for. And we can put this x term, negative 4, into any of these equations. But the one that will give us the answer the fastest is the one that we modified. So let's take that negative 4 and let's put it in place of this x right there. So let's rewrite what we've got. We've got a y equals, and then in place of that x, we're going to put what x is, negative 4, and then plus the 1. So we go ahead and do that work. We're left with y equals negative 3. So we've got our two numbers here. X is negative 4, and y is negative 3. And that's where the two lines end up crossing, at that ordered pair. Well, here's another example of a type of problem you could end up seeing. Again, we have that same situation where it wouldn't be a good idea to solve for x or y here because we would have to do two operations and deal with some fractions. Over here, well, this 2 would cause a fraction when I divide the y by 2. So it's best just to isolate this y. So we can do that by moving this 2x to the other side. So now y is by itself. So I'm left with y equals negative 2x minus 8. So from that point, we can go ahead and isolate or solve for x by substituting this negative 2x minus 8 into y in the other equation. So we're rewriting that top equation, negative 3x plus 4, but 4 is being multiplied by y. So I need to put that negative 2x minus 8 in parentheses. And then this all equals 12. So now I'll go ahead and use that distributive property. Multiply that 4 over this sum. Now I say a sum because they're the same signs. Remember, with same signs you add. So if I could add those numbers, I would. Well, here I have negative 3x minus 8x, and a plus negative 32. or just minus 32. 4 times negative 8 makes a negative 32. And this all equals 12. Well, I'll go ahead and do some opposite operations. Move that 32 back to the other side. I'm doing that by adding it to both sides. And then collect these two terms. These have the same sign, so I add those two numbers. So now I'm left with a negative 11x. This all equals 44. Well, from this point, I need to do another opposite operation. I'm going to divide by negative 11. And when I do that, I'm left with x equals negative 4. Well, not done yet. Still need to find y. Now again, you could put the negative 4 in for any of these x's, but the one that's going to give you the answer the fastest is the one where y is by itself, where we modified the equation, and that's the one we're going to put it in for. So in for that x. We'll get the same answer again with either of those equations, but this one's the fastest one. So y equals negative 2 times by negative 4, and then minus 8. Well, negative 2 and negative 4 make 8, positive. Take away the 8, well, that gives us a y value of 0. So we've got our ordered pair, negative 4, comma 0. Well, one more for this part. And this one requires a little bit more thought. Because again, you want to isolate one of these variables, but which is the best one? We don't want to deal with fractions. And here, if we solve for x, we'd eventually have to divide by 3. 3 doesn't go into 5, so we'd end up with a fraction. Same way if we did it the other way, solve for y. If we solve for this 4, we'd have to divide 4 into 2. Well, that would give us a fraction as well. But if we divided 2 into 4, we wouldn't have to deal with fractions. So I'm going to divide all these numbers by 2. I'm going to modify this top equation. So when I do that, now my new part, again I'll rewrite it down below here, would be x plus 2y equals negative 2. Still have to do one more step, and that is to move this 2y to the other side. So I'm going to do an opposite operation, minus 2y. So now I can rewrite the equation, but it's solved for x, so we can go ahead and use that substitution method. So x equals negative 2y minus 2. So we can go ahead and take that value of x, that negative 2y minus 2, substitute it into the equation. Actually, into the equation we haven't modified yet. So it would be this bottom equation, the second equation. And so we'll go ahead and rewrite that second equation, that 3x. But in place of x, what are we putting? Negative 2y minus 2. So we put that expression in for x. And then plus 5 times by y. And this all equals negative 3. So we can do some work here. We can distribute this 3 over that sum. It's a sum because they're the same sign. And we'll see what we get. So this leaves us with a negative 6y minus 6 plus 5y equals negative 3. We can go ahead and do some opposite operations here. We'll add the 6 to both sides, but I'll also collect these two terms here. And since they're opposite in sign, I'm going to subtract. Now, more negatives than positives, so that's why I'm writing down a negative y, or negative 1y equals 3. More positives than negatives here, so that's why it's a positive 3. Well, one more step. Got to get rid of this minus sign here. So we're going to divide by a negative 1. And so when I do that, the negative signs cancel, and we're left with y equals negative 3. So we can go ahead and now find x by doing the same thing we had done before. So again, you can substitute that -3. You can bring that all the way back over here and put that in for this y would be the best one. Again, you can put it in for any of these y's, but the best is this one where x is by itself. So let's go ahead and rewrite what we've got. X equals -2 times by -3 minus 2. Well, you do this work here, and this makes a +6 minus 2 gives us 4. So there it is. X is 4 when y is -3. So we write that ordered pair as 4, -3. Well, there's the answer. And we've got 2 more parts to go. Part 2 is going to be some word problems, solving systems, and part 3 is a little review.